Let me see. Okay. Cool. So I hope everyone's doing well. Been taking care. I think today we're going to be going over the USACO 2019 December contest silver. So I'm just going to throw a link into the chat just so everyone can follow along. So we're just going to be looking at all three problems. This will take anywhere from an hour to an hour and a half. So just, that's like the general logistics. So should I just let's see. Do you guys know if there's normally more people coming and like if I should wait or if this is the right number? Well, okay. Let's see. Okay, it's already 8:03, so I guess I'll just get started if that works for everyone. Okay, so yeah, we can just first, everyone, just take a look at the first problem. So the first problem is MooBuzz. So here, take 2 minutes to quickly read through it. So I'll just give you guys till 8:06. And just to confirm, could you guys like just type yes, like into the chat if you can hear me? Like, let me know if I need to be louder, quieter. Oh, okay, cool. Yeah, I'll just give you guys a minute to read. All right, so I guess we can just get started. So the problem statement just reads, Farmer John's cows play this game called FizzBuzz, and all they do is they count up, right? They count like numbers up, like 1, 2, 3, 4, 5, 6, ... But instead of just doing that, they also have this thing where if the number is a factor of 3, or if it's a factor of 5, they will say moo instead of saying a number. And they just want us to like give in a number, and they want us to determine what's the nth number that is spoken. So if we can just quickly go over the sample input. So right, the input in the beginning is n equals 4. So they're asking, oops, sad. Let me find a marker that works. Oh, I hope these are not all dead. I have to use these in a semester. Okay, there we go. So n equals 4. And so it's just what's the fourth number that's spoken. So I mean, just right now we can kind of just list it out. 1, okay, this is fine, right? This is spoken because it's not a factor of 3 or 5. Same with 2. For the 3, it gets replaced by like, a moo, m. So that doesn't count as a number. So far we've only spoken 2 numbers. 4, 5 is also a factor of 3. Oh, sorry, 5 is a factor of 5, so it gets replaced with a mu. Same with 6, and then 7 is the next one. That's an actual number that's getting spoken. And so our answer would just be 7.
Oh, we can't hear you.
Oh. Oh, really? Okay. Oh, okay. So some people can hear me, some people cannot hear me. Okay, yeah. So we'll just wait for maybe like 15 seconds to let people who can't hear me, rejoin, and hopefully it'll work. Okay. Cool. All right. Okay, you can hear me now. Awesome. Let's see. Okay, yeah. So we were just saying, okay, one approach is, if we just kind of list out the numbers and determine like, hey, does this one work? Hey, does this one not work? Or like, sorry, hey, is this number going to be spoken? Or is this number going to just like not be spoken and instead replaced by a mu? So that is one approach we could try. And if you look at the bounds, like the possible values of n, they say that given n, where n is between 1 and 10 to the 9th, like those are the possible values of n. Well, if we think about it, this is what kind of approach is this, like in terms of time complexity? The one I just listed out, where we're just going through the numbers, like 1 through ... and just seeing, okay, what's the like nth number that's spoken? Approximately, what would you guys think is the like big O efficiency, computational complexity? So it's like the O of something. So just take a moment, try to, if you have an answer, try to just private message the account that says like Richard Zan parentheses main, because like that's the one on my computer, so I can actually read your responses. But yeah, here, let's give you guys like a minute, just think about it. If you're not sure, you can just throw in a random guess, no worries. Okay, yeah, so as one might imagine, this approach takes approximately linear time. So it's approximately O of n. If we're just, listing the numbers until we reach the nth, like spoken number. Like, okay, you might think, oh, is it O of n or is it bigger, right? Maybe it's bigger because, you have to count out more than n numbers just to find the nth spoken number, right? There's like a little difference because, there's some m's here, which makes you have to check extra numbers. But it is O of n, and actually in a moment when I'm explaining the like the faster approach, you'll actually see pretty quickly why it's still O of n, this original approach. Okay, yeah, but regardless, we know it's at least O of n or greater, and given the bounds, it's just not going to be fast enough, right? Because the limits for an O of n solution generally lies within about like 1 million. So like n has to be like at a maximum, it can be 10 to the 6th, 1 million, in order for an O of n algorithm to be able to finish in time. And so, 10 to the 9th, that's obviously way too big. So we're going to have to think of a faster approach. Okay. All right. So if we kind of just think about, or never mind, if we write out a couple more numbers, we might end up seeing a pattern that we can kind of exploit to help us. So I'm gonna be writing out just a bunch of numbers of like the numbers or an M if they would be replaced with like a mu. So, okay, 7 is spoken, 8 is spoken, 9 is not spoken, 10 is also not spoken, 11 will be spoken, 12 is not spoken because, divisible by 3, 13 will be spoken, 14 will be spoken, and then 15 will not be. And then if we go over here, we can write out 16, 17, 18 will not be spoken. It'll be like mood. 19 will be spoken. 20 will not be. 21 will also not be, divisible by 3, right? 22 will be spoken. Same with 23. Not for 24, not for 25. Oops. 26 will be spoken. Not 27, 28, 29, and then not 30. So does anyone see a pattern here that might be able, that we might be able to exploit to calculate this in pretty much constant time? Okay, well, let's just see here. We'll just test out a couple, just random numbers for n. Okay, let me grab a different color really quickly. Let's see. Okay, so, I'm just gonna kind of label this. So, this 1 is the first spoken number, right? This 2 is the second one. This 4 is the third spoken number. This 7 is the fifth. 7 is the fourth spoken. 8 is the fifth. 11 is sixth. 13 is seventh. 14 is eighth. And then, 16 is 9. 17 is 10, and so on, right? So the idea is this pattern kind of repeats every 15 numbers, right? It's always going to be if you take whatever number you're given, n, and you modulus it by 15, it should lie in one of these kind of positions, I hope that makes sense. Okay, and what else? Let's see. Okay, and I can kind of label this side too. So this is the 0th row. This is the first row, and then we'll have second row, ... Okay, and so now we want to kind of think of a formula that we could possibly use. And so, well, first of all, we can easily see that, okay, for every 8 that we increase n by, if we have an n, right, and we increase it by 8, that's equivalent to taking our number here. Let's say the answer would be A. We know that A should be 15 more, right? So let's just do a quick example. So let's say we are looking at, the first number that is spoken, right? First number that's spoken is 1, right? So if n is equal to 1, that means A should be equal to also 1, right? Because A is the actual spoken number. Okay, now let's consider n plus 8, right? So if we increase n by 8, if we set it to 9, then what should A be? well, let's just see, what's the 9th number, right? The 9th spoken number is, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 16. 16 is the 9th spoken number. And so that, falls exactly in line with what we want, right? For every for every 8 that ends increase by, we know all we have to do is increase a by 15, right? Because essentially what we're doing is we pick a n and then we count 8 more down. And every time we count 8 more down, that's equivalent to, 1, 2, 3, 4, 5, 6, 7, 8. It's equivalent to just going down one row in this little graph thing, right? Because this will always be the 9th number, and then this would be the 17th number, 25th number, da da da. So that's essentially kind of the rule with which we're gonna get our answer from. So pretty much we just need to see well, first, which kind of row this is gonna be in, right? If it's in the 0th row, then we know that we start off with 0 times 15. And then afterwards we see, okay, what is n mod 8, right? We have to adjust it by this amount afterwards, right? So, okay. I'm just gonna write out the formula first, and then we can really quickly just go through what it means, kind of. So formula is gonna look like this: n minus 1 5 by 8 rounded down times 15 plus n minus 1 modulus 15. This is a separate term. So there's 2 terms here, okay? So this first term will correspond to the row. And it's gonna be pretty much, we're always gonna be adding intervals of 15. The second term is gonna be which column is it in, right? And so we'll take a look at that in a moment. All right, so take a moment and look at this, and then we'll just go over a very brief example. Okay, so let's say, for example, let's take a look at, oh, sorry, this is, shoot. Let's just change this into the column term. I accidentally screwed up. It's not, you can't really write the second thing as a closed form. We're pretty much going to be never mind. I'll explain it when we get to it. Sorry. But anyways, the row first. Okay, so let's look at the example of n is equal to, let's say 12. Okay. So for 12, if we just plug into this formula, we see that, okay, if we want the 12th spoken word, right, it's clearly going to be on the row 1, right? And if you plug it into this formula, this floor symbol just means round down. So this term, after you apply the floor symbol, is the row that it's in. And so 12 minus 1 divided by 8 rounded down, that's just 1, right? Okay, and then the column is going to be kind of determined by the remainder. So we take n minus 1, we mod it by 8, right? So n minus 1 modded by 8. So it's the third column. And so we just see, okay, first, second, third is the third column. So, therefore, this should be the 12th number. Wait, I think I screwed something up a little. Let me check. My bad. Let's see. Oh. This should be 0 index. It's a little scuffed. My bad. So yeah, the reason why you have to do all this n minus 1 stuff is just because like, when they're asking for like the, first number, what they're looking for is like, it's a little different from like what you get in arrays, because like, in arrays, things are 0 indexed. The idea is we're gonna put like 1, 2, 4, 7, 8, 11, 13, and 14 into just a 1D array, right? And then we're gonna kind of like get the column to correspond to these values just by using the array indexes. And like array indexes, or arrays are indexed by like 0. It's like a minor detail. Okay, yeah, so that's pretty much it. You kind of like find the row that this number that like n would correspond to, and then you increase it by multiples of 15 as necessary, and then you also find the column, and you just use these values to determine what the actual value is. And so here, we can just really quickly code it up. It's actually a very, very quick thing to code. So I'm gonna screen share my screen, and we can just see how it goes. Okay. Can you guys all see my screen? Please let me know in the chat. Yes, okay, I got a yes, I'll take that. Okay, so yeah, MooBuzz is the first question. Let me open up my Ubuntu. Okay, cool. So I'm assuming you guys are all familiar with C++ because I think that's what we taught this summer. You can kind of just ignore everything up here. It just whatchamacallit, it just reads in like input from file. So don't worry about that. Main code starts here. Okay, so let's see. First, we have to read in the input. So we'll just do that. And it's just one value, right? Very simple. Okay. And then now let's see. We can first determine the row that the number should be in. And so just based off of the formula, n minus 1 divided by 8. So this would be the row that it's that like this number is in. And then we'll add the factor of 15 in a moment. And then let's see the column. The column is going to be n minus 1 modulus 8. Right? Okay. Now calculate actual value. And well, here, let's first create a temporary array. Create temporary array for column values. I'll choose a vector. A vector is basically the same thing as an array. And so for this, we're just inputting the values that we like had written up on the board. So I'm just copying them down right now. Okay, there we go. And then we'll calculate the answer. So it's the row times 15, because for each row we go down, we want to increase it by 15. And then we want to use our column to like kind of map to each of the values inside this array, right? Because if it's in like the third column, we want to add 4 to the number. Or sorry, if it's in like column 2, if it's 0 index and whatnot, then it would be 4. And then you just print it. And yeah, don't worry about copying this down. I'm gonna be sending this to all of you guys anyways. Yeah, so that's should be it. Let's just compile this. So what I'm doing right here, if you guys are familiar with it, is just command line. I forget how much I explained it, but it's just another way of running code. Okay, yeah, so now I just need to make my input file, and then we run it. And it makes an output file, and it has 7, which is good. And I think we're ready to submit it. Okay, cool. So that is the first problem. Okay. Now we'll take a look at the next problem, problem number 2. Okay. So yeah, the next problem is called, or actually, let's skip to problem number 3. Problem number 2 is a tad bit harder than problem number 3. So we'll just go, let's make sure everyone goes to milk visits. I'll send a link just so it's very easy for everyone to get there. Okay, so just really quickly, to kind of, recap on what this question is asking is, we're given a tree. So, once again, a tree is just, it's a set of nodes or vertices connected by edges such that there's no like kind of extra edges and that everyone's connected to each other. So kind of by the nature of how a tree works, it always has n vertices and it has n minus 1 edges, right? Because if you add any more edges after this, you're gonna like, if I add this edge, I'll have multiple ways to get from one node to another. So this is our tree. And basically, Farmer John, he has a bunch of friends visiting. Oh, sorry, did someone say something? Okay. Yeah, feel free to jump in or whatnot. Okay, yeah. So sorry. Oh yeah, Farmer John has a bunch of friends. Basically, it's like given a path, given like a bunch of paths So, like let's say from 1 to 3, his friend wants to drink a certain type of milk. So if and there's 2 types of milk, there's milk G and milk H. And basically for any given path and friend, is it possible for the friend to make a trip along that path while getting to drink that type of milk? So like, for example, let's say you have a friend who wants to get from here, from 1 to 3, and he wants to drink the milk of type H. Well, he's in luck because as long as he passes through a node that has the right type of cow, so this node has cow H, right? Your friend can drink the milk from cow H. And then same thing for G, right? If he wanted to go from 1 to 3 and he wants to drink from a cow G, when he gets to 3, he can drink from that cow G. An example of where things might go badly is, let's say your friend wanted to take a trip from node 1 to node 2, so just this path, but he wanted to drink the milk of cow G, right? But unfortunately, there's only cow H's along that path, so that would be a case where he doesn't get to drink. Okay, and so that's the problem. There's a couple ways of, I guess we can first talk about the naive approach. Okay, so you're given m friends, basically n, m journeys, right? It's just 3 numbers. It's 3 things. It's the start and end destination plus whether or not your friend plus the type of milk your friend wants to drink, right? So 1 to 2, your friend wants to drink cow G's milk, and that would not be possible. And so one approach is you have m of these trips that you have to process, and so if you just process them each one at a time and just kind of do a DFS, right? You go into this node and you look for the path, and if along that path you find a cow that's like the right type of cow, then you're good. If not, you're not good, right? That is one possible approach, but we have to think about the computational complexity of that approach, right? For any given journey, it can, in the worst case, take up to O of n time to do that journey, right? To find the path. So if I find the path from 1 to 2, that might take O of n to time. And then later they're asking me to check from 1 to 4. Could be also O of n time. I'm pretty sure, I think we covered DFSs in the summer, maybe. But yeah, just let it be known that that type of approach does not work, because you have to do an O of n operation m times, right, for each of these journeys. And if we look at the bounds for this, right, n can be up to, was it like 50,000? Let's see. N can be, sorry, just 100,000. And then m can also be 100,000. And so, that would leave this at like 10 to the 10th, right? Multiply them, and that's definitely no good. Okay, so we have to think of something faster. Well, here's the thing. If we do for these types of problems where they have a bunch of queries, by query, I mean they're asking you a kind of a question, right? Query, question, same thing. They're asking you a question like m times. Sometimes what you can do is you do a little bit of pre-processing, like you calculate some stuff beforehand, before even looking at these, and then that'll let you answer each of these queries or questions a lot faster. So in this case, the type of pre-processing we want to do, it's going to be kind of looking at, instead of trying to determine or help us determine if something is possible, it's going to help us determine if a trip is not possible, right? Like if it's not possible to get from 1 to 2 and drink milk G, right? So the way we know that it's not possible to get from 1 to 2 without drinking milk is, if you just kind of look along the path, they're all H's, right? So if the path from any node to another node is all H's, then we know that it's not possible to drink milk G along that path, right? And so what we kind of want to do is we're just gonna kind of group nodes together, so that we know that if we're trying to get from any node to any other node in that group, it's only possible to drink one type of milk. You can't drink both. So the group that we would create from this graph would look like this. So we have one group which consists of 1, 2, and 4, right? Where you can drink the H type milk. We have one group that's just 3, you can drink G. Then another group that's just H. That's just G. And you can drink, that you can only drink G, and it's node 5, right? So essentially, what's happening is if, our friend wants to take a trip from, 1 and go to 4, then we know that they can only drink milk H, right? So if you're picking 2 numbers as the start and end points from the same little bubble, group, we know that you're only allowed to drink this kind of milk, right? Okay, but what about a situation where I'm picking 3 and 5, right? They're not in the same bubble, but they still have the same type of milk, right? What's gonna happen there? Well, if we look at just the graph, basically what's happening is you start at a node that is you can drink G from, but you have to pass through other nodes where you can drink H from, right? Because basically, if there was a possible path from 3 to 5 with only G's, only nodes that have cow G, then these would be in the same group. But because they're not, we know that we have to pass through some nodes that are not H's, and therefore you can always drink both types of milk along that path. Okay, so now that's what we want to be able to do after the pre-processing. And so if we're gonna think about, how can we allow ourselves to do this, right? We're gonna be using a technique, algorithm, concept, I don't know what it's called connected components. And I don't know, maybe another term you guys have heard, it's called flood fill. This is kind of an idea that's used in connected components. Basically, we want to separate, the graph into nodes that are connected, such that, you only have to pass through one type of cow to get from any of these nodes to another, right? Okay. And so to do connected components is not that bad, honestly. If you're familiar with DFS, DFS is depth first search, deep depth first search. And, I'll just quickly go over how that works. So the idea is we're going to have an array that kind of stores the, I guess you could call it group that each of these nodes are in. So in the beginning, no one's going to be in a group yet. And we'll just kind of, I guess, signal that by saying everyone's in group, or no one has a group, right? This array will just be all zeros, right? So node 1 is not in a group, node 2 is not in a group, same for everyone else. Okay, and so what we're gonna do is, first we're gonna kind of have a for loop that looks through each of these positions in the array. And every time it comes across a position, like a node, node 1, that does not have a group yet, as indicated by the fact that this is a 0, we're gonna perform a depth first search into it. So what we're gonna do is we're gonna look at group 1, we're gonna say, okay, you're not in a group yet, we're gonna make you the start of a new group. Let's just call your group 1. And we're gonna do a depth first search on you. So we're gonna basically look at you, we're gonna look at your surrounding neighbors, right? So the neighbors of 1 is 2 and 5. And we're gonna say, okay, number 1, are they the same type of cow as us, right? Did they have the same type of cow? Okay, well, 5 doesn't, so we don't do anything there. But 2 is the same type of cow. And then the next question is okay, are you in a group yet? And 2 is not in a group yet. So we're going to make it part of our group, right? And that makes sense because 1 and 2 are supposed to be, in the same group at the end of the day, right? You can get from 1 to 2 without and only go through one type of cow, right? You're only visiting cow H. So we're going to put 2 into our group, and then we recurse, right? We're going to do recursion, and we're going to do the same thing to this node. We're going to look at all of our neighbors. So neighbors are node 1, 3, and 4. Okay. First, we're going to say, okay, which ones have the same type of milk as us? That's just going to leave us with nodes 1 and 4. And then we're going to say, okay, for 1 and 4, which one of these have not been assigned a group yet? Okay, well, we see that, 1 has already been assigned a group, because, like it was the person who gave this, the group number, right? 1 already has a group, and then 4 doesn't have a group. So we'll just put it in the group, same group as us, right? Everything still makes sense, right? Because these are supposed to be in the same group because, you can get from one of them to any other of them just by staying on, cow H nodes. Okay, and then, we recurse on 4. We see that, okay, 2 is the only neighbor. Yes, it's the same type of cow as us, but no, it has not been assigned a group yet. Or sorry, it has already been assigned a group, so we don't have to recurse on it. And then that's it for this first DFS. And like I said, remember, we're doing a for loop over each of these and looking to see if they're not in a group. So our for loop has already finished this one. Now we're going to go to the next one. We're going to see, okay, is this one part of a group yet? Yes, it is. So it's been checked. We're good. We don't need to do anything there. Now we see, okay, node 3 has not been assigned any group yet. So we're going to make it its own node. Okay, or sorry, its own group. And we'll just call it, it can be group 3, right? Just based off of the node. As long as these are unique numbers, we're fine. Okay, so it's node 3. It is its own group. And we do the recursion, DFS. Well, I mean, the DFS ends pretty quickly because as we're looking through its neighbors, we see that it only has one neighbor and that neighbor does not have the same type of milk as us. And so we're going to not recurse. And so we're done. That's it for the DFS for 3. Okay, so we continue our for loop. We go to 4. We look at it. Oh, it already has been assigned a group, so we don't need to do anything else. We look at 5. Okay, well, we are going to make you your own group. And then we're going to go here. We're going to do our DFS, recursion. Look at your neighbors. Your neighbor is 1. Oh no, it's a different type of cow. So we do not need to keep recursing. And then this, right? It forms our groups, right? Because 1, 2, and 4 are in a group. 3 is in a group, and 5 is in a group, which is exactly what we wanted originally. Okay, so that's the idea behind how we can get this pre-processing, or do the pre-processing, right? And then afterwards, just to recap, right? If we're given a query, right, like the journey, the start, end, and the type of cow it wants, right? Let's say it's 1 to 3, right? We see that these are in different groups, right? Just by looking here. So clearly we're going to be passing through both types of cow. So we don't need to worry about anything really, right? We don't need to worry about no matter what, we will be able to give that farmer the type of milk he wants, right? We're passing through both types. An example of where it wouldn't work. Okay, let's see. Okay, node 1 to node 4, and you want to drink G, like cow G's milk. Well, we see that, okay, they are in the same group as denoted by the fact that, they have the same label, same number there. So then we check, okay, we have to look more carefully. Okay, what type of milk do they serve at these nodes? It's all cow H's milk. And so we know that we cannot, give the person the type of milk he wanted, which was cow G, right? Okay. That was, oh yeah, and before I start doing the coding, really quickly, it should be clear that to process each query now, we can do it in constant time, right? O of 1, because we just look, okay, are you guys in the same groups, right? If so, what type of milk do you serve there? If not, then we know you're fine, right? That's all constant time stuff. It doesn't depend on the number of vertices, right? Because it's all been pre-processed. And I guess another thing to look at is how long does the pre-processing take? Okay, so the idea, or the way I see it generally is it should be O of n, because like if you think about it, okay, the for loop itself is repeating n times, but the way I like to see it is the amount of how many nodes are you visiting or processing with the depth first search in total, right? In total, you're only ever going to process n nodes, right? Because once a node has been put into a group, we're never recursing on that node again. That's the idea. So each of these can only get processed one time. So that makes up for a total of, n processed things, and you can never really exceed that. It's not going to be, n squared or anything. So therefore, the pre-processing is O of n, and then the afterwards processing each query takes constant time, O of 1 time. Okay, so we're good with that. I'll pause for a moment. Let me know if you have any questions, and I will set up my screen share again. Okay. Yep, this is the question. And let's see. Oops. Okay, here we go. All right, so first thing we're gonna do is we're just gonna create, oh yeah, and I'm just putting these variables outside here because I want to make them global. The only thing I mean by that is like if I have another method here, right? I want to be able to access n and m, and I can. Like, I guess that's all you really need to know about that. Okay, so we're first going to set up our like the data structures for all the things that we're reading in. Okay, so right, I created all these variables, and now I'm going to read in their values. Right, so the first three things that are read in are n, m, and then the string. So I'm storing the string inside the variable called cow milk. Just make sure this compiles. Okay. And now I'm going to read in, oh yeah, and just one thing I'm going to do really quickly. I'll explain this in a bit. I'm just going to offset this string by, like, I'm basically just putting a space in front of the string, and it's just some indexing stuff. So I'll explain that in a moment. Okay. So now I'm creating this. Wait, have you guys seen vectors? Can you remind me? I feel like I asked this in the summer too, but I always forget. Just let me know, yes, no, have you heard of vectors before? They're similar to arrays. Anybody? Let me know through the chat, please. Yes, okay, cool. Yeah, so here I'm just, so this variable is called con. It just stands for connections. It's like what I typically use. It just kind of denotes what are the connections between the nodes in the graph, right? This is what you might have heard this term before, adjacency list. It's going to be our adjacency list. Okay. So it's a vector of vectors, two-dimensional array, basically. Okay. Now I'm going to start reading in these things. So we have n minus 1 edges. That's the next thing we're reading in, right? All these things are the edges. It just means that, 1 and 2 are connected. So I'm reading in the two numbers on each row, and then for each of those two numbers, I need to put them into the array. Oh yeah, so I guess vectors are kind of, if any of you guys are familiar with Java, vectors are like array lists, as in they're basically arrays, but you can also increase the size of them later on. You don't have to define their size in the beginning. They can increase. So here we go. So basically I'm just saying, okay, right, there's an edge that goes from A to B, and then there's also an edge from B that goes to A, right? Because these edges are undirected, it goes both ways. Okay, and next, I'm going to just initialize this last vector, just group, right? Kind of mentioned that it's going to be used later in our DFS. Okay, so reading in input. And then here we have the end of reading input. Okay, so next thing we're going to be doing is we're just going to kind of, do the for loop. So this is the pre-processing step. Pre-processing step. I guess I can get rid of that. It's kind of all goes together. Okay, so pre-processing step. All we're going to do is we're doing our little for loop. Right. As a reminder, this was called connected components. We're kind of trying to separate the graph into groups of nodes that we know are connected, right? So we want to go from node I, process node 1 to node N. And for each of them, we check, okay, has your group been assigned yet? So if group I is 0, then the group for node I hasn't been assigned yet. And then we will do the assigning by calling the DFS on it. Okay, so our DFS is going to take in two arguments. One is the current node. And then I just like using color. It's like the group number that we're assigning it, right? And so the first thing you do is you just say, okay, well, the group that this is in is color. And then we're going to look through each of our neighbors. Right, this looks through it looks through all the edges that start from cur, right? If you're not familiar with this, this is just a for each loop. Basically, the first part is kind of like an element of the second part's elements. Okay, sorry, let me explain this. The second part is going to be something that's iterable. So for now, just think of it, the second part has to be like an array or an array list or like a vector. And then this is just going to go through each of the elements of the vector. And like this next variable is going to be each of those elements. So like, for example, if you had like an array that was like, 2, 3, 4, next would first be 2, and then it would do another loop where next is 3, and then another loop where next is 4, and then it would be done. Okay. And so we're doing that, but for all the neighbors of cur. So as long as the group of next has been not assigned yet, and I guess the way I did it originally is you first check the color, or sorry, the cow. So as long as my cow is the same as their cow, right? As long as we're serving the same type of milk, right? Either we're both cow G's or we're both cow H's, and your group has not been assigned yet, right? By it being 0. I guess I'll just put a comment here. Checks if my the cow at the current node is the same type of cow as the one at the next node, the neighboring node. And then checks if The other node has not been assigned a group yet. Okay. So as long as both of these conditions are met, then we're going to recurse on the next node. And, of course, we're going to give it the same color. There's like the color is the group. Sorry, it's such a weird name, but yeah. Okay, and that's all the pre-processing that's going to go on. Let's see. Yeah, and then now we can just process each query, aka question. Farmer. Okay, so we're just looking through each of the queries, and we're actually still reading an input at this stage. So let's see. We're going to need so, right, for each of these lines, we got to read in 2 numbers and then a string. Right, read in the input. And then we're going to check, okay, A and B, right, integers A and B are numbers that represent the nodes we're looking at. So first we want to check, okay, and actually I'm just going to make a method that says like, that determines whether a given journey is valid. Okay, so if the journey, right, if the group that A is in is equal to, or is not equal to the group that B is in, then we know that this, like, it's always possible to give the farmer either type of milk, right? Because if they're not in the same group, it means you're crossing both G and H nodes at least one time. So we can always return true here. Okay, and so now assume that they are in the same group, right? Okay, so if this first if statement doesn't get triggered, we know this is true. And if that's true, then if the cow milk, or if the milk that the farmer wants to drink is not, or sorry, I guess we can just return this. We just return milk is equal to, what am I looking for? Cow milk at node B, right? So like cow milk is a string, but you can access the characters like this. And so by accessing the A-th or the B-th character, we can see what type of milk is served at the A-th or B-th node, right? And so the whole group has the same type of cow milk that's being served. So we can just, arbitrarily, we just say, okay, let's just look at the milk that's being served at cow A or at node A. And if that's the same type of milk that the farmer wants to drink, then that's perfect. And oh, I think someone's mic is on. But yeah, anyways, right? If it's the same, then we're going to be returning true here. And if it's different, then we're returning false, right? That's all there is to it. Okay, and then we just got to finish this part out. So if, then we're just going to, kind of use our helper method here. Then we're going to print out A1, right? And if it's not valid, then we were supposed to print out a 0. And then we'll just print out a new line at the end, right? Because it wants the output like this, where if it's possible to do this journey and give him the right type of milk, then we do 1. And if it's not possible, then we print out a 0. Okay, so hopefully after I make the input file, this will work. oops. Oh, I typed PB somewhere, didn't I? Sorry, this is just supposed to be pushback. Pushback just means like add to the back of the array. And then, oh yeah, so here, milk is a string right now, but we know it's always a 1-character string, right? Because it's always either H or G. But this method takes in a character. So what we do is we just access the first character, or the 0th character, I guess you could say. Okay. Oh yeah, by the way, just running dot slash a dot out just runs the code. Oh, so I have a weird dot out. Oh, my bad. I forgot to do this. Oh, sorry, I'm just recompiling. I forgot to do a tiny part. Okay, so we have our in file. We look at our out file. No way, it's what we expected. So that's perfect. And just to make sure everything's running well. Oh, wait. There we go. Okay, cool. There we go. So that is the 3rd problem. It's the 2nd problem we covered today, but yes, it was problem 3. And now we'll take a look at problem number 2. Oh yeah, if you have any questions, I'll give you guys here, take a look at the 2nd problem. I'll send the link to the chat. But if you have any questions about the problem we just covered, let me know. And I'm very happy to talk about it. But yeah, so just in the meantime, take a look at the last question we're going to be talking about today. Just the last question in the contest that we're looking at. This one's pretty tricky, I'll be honest. Definitely trickier than most silver problems I see. So yeah. Oh yeah, by the way. Oh yeah, I think Hubert, I think you have your mic on. We can hear a little bit of background audio. So if you could mute it. Perfect, thank you, man. Oh yeah, I'm just gonna give you guys 1 minute to read through this. So at 9:07, I'll start covering it. Oh, whoops, sorry. I give you guys a little more time. Okay, yeah, so we can just take a look at this problem now. Okay, so problem basically saying, okay, you guys might have actually heard of this problem before. It's normally, or the way it normally goes is like you have a bunch of ants and like they're walking back and forth and they bump into each other and like they'll switch directions. Okay, sorry. Anyways, okay. So what the problem is asking is, okay, you have a line and on the line are two barns. So the first barn is at location 0, and then the next barn is at location L, and you have a bunch of cows that are going either to the left or to the right. And so, and so basically, if two cows bump into each other, they're just gonna switch directions, right? So like this is cow 1, this is cow 2. They're walking, then they'll bump into each other and then they'll switch directions. Right? And then, this is just gonna keep happening, and then until eventually a cow is gonna reach one of these barns, right? These barns. And then once they reach a barn, like the cow stops walking. He just, chills out at the barn. And then essentially what they're asking is like, how long will it take, or sorry, how many times will these cows bump into each other, or I think they call it like meet each other, before half of all the cows' weights are inside the barn. So give me one more moment to explain what that means. Each of these cows have some weight. They weigh some amount. Maybe this guy is 2 pounds, maybe this guy's 3 pounds. So they're basically asking, okay, so how long, or we're gonna keep letting these guys bump into each other until at least half of the cow's total weight is inside these barns, right? So like in this case, once this guy gets it, if this guy gets into a barn, then that's 3 pounds out of the total 5 pounds that the cows weigh, and then we stop counting these meetings and stuff. Okay, cool. That's the whole problem, right? Except it's not just 2 cows. There's going to be a lot more cows and a lot more bumping or meetings. And our task is to count, okay, how many meetings are there? Right, so this is a pretty tough question, I'm gonna be honest, but all it requires you to do is make a couple key observations. So first thing let's look at is, let's look at the order of these cows, right? So let's just, and when I say order, I mean like, the order of them from left to right. Let's just say this is cow 1, this is cow 2, cow 3, cow 4, okay? So, these cows are moving, and then I think probably, so these two are going this way, this guy's going this way, and that guy's just going on his own that way. And so the first thing that's probably gonna happen is like, cows 1 and 2 are gonna bump into each other. And then, cow 3 will probably be a little more this way. And cow 4 is probably a little more that way, right? I just realized, is this a lot of glare that's on? Here, let me turn off this light in the middle. Is that better? Is it easier to see the board this way? Yes, no, maybe so. I also realized I'm writing really small. But okay, hopefully you guys can see this better. But yeah, this will be the first meeting, right? And then, maybe this guy walks more that way. Cow 2 and 3 bump into each other and they switch directions. So now cow 2 is here. Cow 3 is this way. Cow 4 is also just keep chilling. And then I think, it'll just eventually end, right? There's going to be no more meetings. Okay, so one thing to notice is, first, the order of the cows never change, right? The cow who started out furthest to the left is always going to end up furthest to the left, right? And then same thing, the cow second from the left, always gonna, stay second to the left, so on, right? That's one important thing to note. Okay, another important thing to note is, like, we can kind of pretend, we can kind of imagine, I guess, that these cows, they don't really have to, like, bump into each other and switch directions, right? They could, like, it's almost as if they just are kind of like walking past each other, right? Because they're all walking at the same speed. It's just one of them's going, so some of them are going left, some of them are going right. But like, when cows bump into each other, it's as if, you could say, like, if they just walk past each other instead of bumping, they're moving at the same speed. There's always going to be cows at those two locations that, like, they're going. And so we can kind of pretend that they're just walking through each other. And this can help us get to the first part of this problem, where we're trying to determine up to which time, like up to which time point will these cows be, what am I trying to say? To which time point will these cows or how much time will it take for half the cow's weight to be in one of these barns, right? That is a possibility. And so, like, the reason for that is, if we're just seeing, okay, or if we're just saying cows are like walking through each other instead of really like bumping off each other, well, how much, like, we know that there's going to be, like, this cow, if it's just walking down here, right? We know it's just going to take, like, if this is at location X, it just takes X amount of time for this cow to get here, right? And then if it, this guy is at location Y, we know that cow 1, if he's just walking through everyone, it takes L minus Y time for him to walk through everyone, right? And eventually there's going to be a cow reaching here at time L minus Y. Okay, and the reason why, okay, so basically now we know that, we pretty much know that at certain times there are going to be cows that are reaching each of these sides. And I think let's just do it with concrete numbers really quickly, just to make sure it's very clear. So, like, let's say the second barn is at location 10, and then cow 1 is at location, let's say 2. This guy's at location 4. This cow 3 is at location 6. Cow 4 is maybe at location 7, right? Okay, so if we look at cow 4, we know that someone is going to be arriving at this barn at time 3. And then if we look at cow 1, we also know that someone's going to be arriving at this barn at time 8, right? Because it takes this guy 8 seconds to walk over here. Okay, similarly, this to here, cow 2 going to the left barn will take 4 seconds. And cow 3 going to the barn here will take 6 seconds. Okay, so now we're going to combine the two facts we were thinking about earlier, and we're saying, okay, the order of these cows, like, cow 1 is always going to be the leftmost, right? And so we know that the leftmost cow should arrive at this barn the earliest, right? And so we know that this guy will arrive here at time 4, right? So cow 1. And then we also know that cow 2 is, the second cow from the left, and he's going to be here at time 6, right? Because that's the next leftmost cow, right? And then for here is the same thing, right? The rightmost cow is going to be here at the earliest time. So this is the rightmost cow. He's going to be here. This is cow 4. And we know that cow 3 arrives here. Okay, so this is how we are going to be able to determine what time are half the cows going to be at these barns, right? Because then we can kind of just like sort these times and just say, okay, first, cow 4 gets to a barn, cow 4 weighs some number of pounds. we put that into we store that, right? And then we see, okay, cow 1 arrives next at time 4, put that into store that, right? Cow 2 then arrives at cow 6, okay, and maybe at that point, half the cows' weights have reached a barn. Yeah, and so that'll help us get T. So, okay. I think I can do some of the coding for that first. So let me screen share. Okay, so we first start out by just reading in all the numbers. So we start out with an N and an L on the first line. And then, oh yeah, one thing I forgot to mention, yeah, these cows are not sorted, or like, they're not guaranteed to be sorted. They just happen to be sorted by X coordinate here, but we do want to sort these by X coordinate. So I'm just gonna kind of create a temporary structure that will allow us to sort these cows by their X coordinate. If what I'm doing here isn't completely, like if you guys haven't seen this before, that's fine. Just like the only point of this is that I'm using an extra data structure to help me like store this cow information and sort it. So here we go. We can say that just input. We know that there's N cows, and we're going to read in their information. And we're going to put them into our vector. We're putting each of the cows into our vector. Once all the cows are in our vector, we're just going to sort it. Here, let me add a little comment. Sorts cows. Just more sorting stuff. And now we're going to actually make the arrays that are like holding all our information. So the first thing is going to be our weight. So we store that in an array called W. Then we have our X coordinates. Then we have our like directions. I guess we can just do W, X, and D, right? W is weight, X is the X coordinate, and then D is the direction. I guess I can put that into a comment. And now we just process each of these. Okay, and all right, so we also want to calculate, okay, what is the total amount of weight of these cows? Because we later want to check, have we hit at least half the cow's total weight? Just compile this just to make sure everything's going well. oops, sorry. I normally have a like macro, just something that allows me to type PB instead of writing out the full pushback. That's not bad. There we go. Okay, so everything compiles so far. Calculate total weight. This part is creating, storing information into arrays, the sorted information. And now what we're gonna first do is we're gonna calculate the number of left, like cows that end up on the left side. So if you think about it, like the number of cows that start going towards the left will be the same number of cows that end up inside the left barn, right? Because for any given collision, you start with one cow coming in from the right, one cow coming in from the left, and then they bounce off each other, and it's the same number of cows going to the left and the right. It has no effect. So we want to count the number of cows that are going to the left. And we also want to store the number of, or like the times that cows will reach the left/right barn, right? This was kind of the last thing I mentioned, right? Where we're calculating, oh, okay, a cow will reach the left barn at time 3 and 6. A cow will reach the right barn at time like 4 and something, right? That's what we're doing here. So we can just call these left times and right times. And so checks if the is going left. Okay, so if the cow is going left, then we know, okay, we can increase the number of cows that are going left, right? And we can save this number, right? Like if it's going to the left, then we know that whatever its position is, we can push back into the left times array, right? Because it'll take that much time for it to reach the left barn. And it's a similar idea for the right side. Except for instead of just doing x, it's just L minus x, right? Because it's going from position x to the Lth coordinate, which takes L minus x time. Okay. Let's see. Yeah. Now I'm gonna have a vector of a pair of integers. So this is just like an array of pairs of integers. I'm gonna be sorting this. This is kind of like how do I describe this? Oh yeah, this is just basically it's kind of like storing events. It's storing the time that any cow gets to a barn and the weight of that cow, right? And then we're going to sort this and we're going to process it in order from earliest to latest to determine the total amount of time it takes for a cow to reach either side. Or like, sorry, the total amount of time that it takes for half the cow's weight to reach a barn. So I'm just gonna type out a little bit of it and I'll explain after some of it's down. It'll make more sense that way. Okay, so I guess I'll group this all together, just saying sort the events where cows reach either barn. Okay, so what we're doing is we're looking through each of the cows in order from left to right. And so for the first, like this essentially says for the first L num, like for the first number of cows ending up on the left side, we're going to look at all of them and we're going to put them into our events array or ends array. And in it, we're going to store two things. We're going to store the time that they reach the left barn plus the weight of the cow that reaches the left barn at that given time. And then this L count is just to kind of move us along because the L times is sorted, right? Okay. And then afterwards, we look at the all the cows that are ending up on the right side. And then we're going to be putting them into the same events array but now instead of using the left times array, we're using the right times because these cows are ending up in the right barn. And we're also putting in the weights of those cows. Okay. And then, oh yeah, and don't forget to sort this array. I never really like ends. I can use events. Okay. Oh, not weights, just W. Okay. All right, and now we're in the home stretch. Okay. Sorry, it's taking a bit longer than I thought it would initially, but no worries. Okay. Now we know, like, let's say, oh shoot. Oh, my bad. We are not done with the coding yet. Very close here. Yeah. And now, we actually want to calculate T, like the time that it takes for, half the cows to go into any given barn. Yeah. And so, we're just storing, the current amount of weight that's we've processed. And so we look at, each given event and we add the weight of the cow for any of these events. Oh yeah, so first, and so this is like, you can access these numbers that you put inside a pair by using the dot first, dot second. So, the second thing is the weight. And so if the current amount of weight is at least half of the total amount of weight, then we know we're done. And we can break. Okay, now I can actually get back to the whiteboard real quick. All right, so now we know that T time has been made, right? Okay, and so if we kind of think about it, we really only have to, like, we'll know that a crossing has occurred if two cows are within 2 times T distance, right? Because we said, okay, let's pretend as if the cows don't actually bump into each other, but they're just moving through each other. And then, if they cross each other, we'll count that as a meeting, right? So these two things, cow 1 and cow 3 will cross if they can, cover this amount of distance within T time, right? Well, each of these cows is moving 1 unit at a time. And so it takes them, or they can, if their distance is less than or equal to 2T, then we know they're going to cross. Yeah. And the way we can quickly count that for all of these guys is by using a queue. I don't know if you guys, I think we covered this. Queue is like first in, first out. So if I put in, numbers, I can push and pop them. Push means like insert, pop means remove. So you always kind of push from the front and you pop from the back, right? Or sorry, we push things into the back and we pop them out of the front, right? So if I put in the 3, then a 5, then a 7, then an 8, and I want to pop it, first the 3 comes out, and then if I pop it again, then the 5 comes out. That's just, and it does this all in constant time. What we can do is like, we pretty much process each of these cows from left to right one more time, and we just say, okay, if we're going to maintain a queue of cows going to the right, and so, you know, cow 1 is going to the right, so we put them in the queue. Then anytime we find a cow going to the left, as long as this cow is within 2 times t distance of the first cow in the queue, then we're gonna, you know, just add, or we're gonna like count that as a meeting. If it's not, we're gonna discard the first cow in the queue and move on to the next ones. And so, you know, in this case, oh, okay, you know, let's just say t is equal to 2, right? Okay, if t is equal to 2, shoot, sorry, let's just say 1, right? Then let's say, okay, these guys will meet, right? Because the distance is 2, which is less than or equal to 2 times 1. So that is at least 1 meeting, right? And then we're gonna process the next cow. This is cow 3, he's at location 6. Okay, we see that 6 and 2, right? It's more than 2 difference. So we discard this. Okay, and then we see, okay, the queue's empty, so we don't do anything there. Process the next cow. Okay, we put them in. But you know, there's nothing there. So there's no more cows. So in total, there would be 1 meeting, which would make sense, right? If these guys only moved 1 distance. That was a really quick example, but I was trying to make this a 90-minute thing. So this is a bit rushed, I do admit. Sorry about that. Okay, but anyways, that is the idea. I'll just quickly write down the code and explain it, and then I'll send it to you guys, and you can look over it more on your own time. Okay, so let's just write this out. So this is how you make a queue. You just do queue. It's going to be a queue of integers, and then we're going to be processing each of the cows with this for loop. And for any of the cows, if this cow is going in the right direction, then we're just going to put him onto the queue, or put his location onto the queue. Otherwise, if it's a left cow, and we compare him against the front of the queue, and first, like, you know, we make sure that the queue is not empty by checking that that the size is greater than 0. So as long as it's within 2 times t, then we're good. And if this is basically saying, you know, if the distance between the front of the queue and the front of the queue and the current location, the current x coordinate is greater than 2t, then we'll pop it out. And then we know that after this while loop runs, everything on the queue will, like, you know, perform a meeting with the current cow we're processing. And that is it. Let me add some more comments here. Okay, there we go. Okay, let's just run it quickly, make sure this has no bugs. maybe I have an infinite while loop somewhere. That is a little awkward. Not bad. Okay, let's see. Sorry about this. Okay, since I have a bad alloc. Sorry, I'll just take a moment to debug this. Okay, I'm gonna spend 5 minutes debugging this because I don't want to hold you guys too long over. So if by 9:45 I'm not done with this, it's fine. I'll just let you guys go. I explained pretty much the algorithm, and I'll just fix it, send it out in an email. And yeah, just for all 3 of the problems we went over today, I'll send out an email about what is going on with like all the code that we covered. I'm really not sure what's wrong. Oh, I forgot to put in that again. That is my bad. I'm gonna get rid of these debugging messages first, and then we can take another look. There we go. I do not think that's what we wanted. Whoops. Okay, so the T of 5 seems like it should be fine. Oh, actually, no, the T of 5 is. I think T should be 2. I screwed up somewhere. That's not bad. Oh, okay, I see one thing. This said L count, but it should be R count. That's definitely my bad. Wasn't the only issue. Events. L count 0, R count is 0. I 0 to n minus 1. y is less than just doing a little debugging right now. Oh, it's definitely not right. Oh, seems like I screwed up pretty early on. Let's see. All right, well, it is 9:45 and I said I'd let you guys go, so really sorry about this. I had even written up the code beforehand and I'm looking through it right now, but I don't really see the error yet, so I'm just gonna spend some time on my own looking through this stuff. And then yeah, I'll send you guys an email afterwards. I think I'm just gonna post it to the group. But yeah, I hope this was helpful for you guys all, for all of you guys. See you guys next week. Bye-bye.
Thank you. Bye.